So in my previous lectures, I have discussed the ways in which we could control the flow of the threads or the process. But in this video, we are going to discuss and focus more on a bit more fine-grained process control. So what if you want to pause a specific thread or check its status or resume it later or even kill it entirely based on a trigger? So last time we have only two types of process control. Those are wait fork or disable fork. So these are just fine for like certain conditions. You could just wait the flow of the code till all the process or threads are completed, or you could just disable all the forks. But in this video, we will go through more fine-grained process control. So without any further delay, let's begin with an example. So I will write a module and call it test. So to achieve a more fine-grained control, we need to use a built-in class which is called process, and I will declare two handles of those class. So this is the class, and let's call two handles as proc1 and proc2. So I will declare two counter variable and I will use it later in my code. Let's call the first variable as I, and let's call the second variable as j, and let's assign a value of 1 by default. So in this video and in this example, I will declare two tasks. So my first task will be called thread1, and inside this task I will write a forever loop. So inside this forever block, I will increment the value of I every 2 time units. So I will just write 2 and it will increment every 2 time units. So I'm using the post increment operator. And after that, I will declare another task. I will call it thread2. And inside this, I will write a repeat block. And I will make it repeat for 7 times. And in the repeat block, after every 4 time units, I will multiply the value of j, which is 1, with 2. And I will just simply write like this. So whatever the value of j will be, it will keep getting multiplied. And unlike the thread1, it is not an infinite loop, so it will only repeat for 7 times in a row. So after this, I will write an initial block, and inside this initial block, I will write a fork join block, and I am reusing a regular fork join, which is blocking in nature. And here I will mention both the tasks, thread1 and thread2. So now we are going to use our process handle, and I will show you how you could assign the process control to each of the threads. So to assign these handles to each of the threads, we just have to use the self method which is present inside the process class. So let's use here process1, and here we will use the scope resolution operator since we are referring to a method which is present inside a class, not inside an object. So we will write process. So it is very similar to what we will do using the get method to create a class in UVM library. And inside the process method, inside the process class there is a method called self. So what this does, this gets the handle of the thread. So it is thread 1 in our case. So it gets the handle of the thread and assign it to the handle. So here we are just getting the handle of the thread 1 and assigning it to the process proc1. So we will do the similar thing to the thread number 2, and for this we will use proc2. Again we will use the scope resolution operator. So what this does, this allows us to control the flow of the process in even more better way. So using this we could just use 4 of the following methods. And those 4 methods are suspend, resume, await, and finally the status. So the suspend method pauses the flow of the thread. So it pauses the flow of the thread and it will not be resumed until you use the resume method. And the await method is a bit different. I will show you in the example. So it just blocks the flow of the statement. So while using the await method, whatever is written after that particular statement will not execute till that particular process completes. So it will become more clearer when I will show you the example. And the status method is an enum type which shows the status of current process. So it holds 3 values. Those 3 values are running, which states that the process is currently running, and suspended, which says that the process is paused, and finally finished, which says that the process has been finished or it has been killed. So, and yeah, there is another method which I forgot to tell you. It's kill. So like the name suggests, it just finishes the process and it kills the process. So without any further delay, let's begin with an example. So first I will just write another initial block in parallel. And this initial block will function as a master controller for all the threads. And here we will be using all these five process methods. And we will use this method using the handle. which are present inside both of the threads. So first, let's find out what will happen with all the loops. So with this loop, after every two time units, the value of the I will be incremented by 1. So it will start with its initial value of 0, and then it will just rise up to 1, then 2, then 3, then 4, and it will keep going on. And with this particular loop, what will happen? So it will first start with its initial value of 1, and then it will get multiplied with 2, and then again it will get multiplied with 2 to get 4, then we will have 8, then we will have 16, and since there are 7 repetitions, we will have 32, we will have 64, and then finally we will have 128 in the last iteration. So here first we will use the suspend method. So I will do that at time slot number 3. So at 3 time unit, what I will do, I will suspend the process 1. And right after that, at 10 time units, I will just stop the simulation. It should be $stop. So what is going to happen here? So as I have told you, suspend just pause the process. So what will happen? So at the 0th time slot, we will have our initial values of I and j. And yeah, before that, just to check the values, I will write a $monitor system task right here. And here I will print 3 things: time, and then I will use, then I will print the value of counter I. And then I will print the value of counter j. So here, since we are just a second, I forgot to use suspend. Okay. So here what we are doing, we are just suspending the process at time unit 3. So what will happen? Our flow of the code will start with the initial value of I, which is 0, and j, which is 1. And then at time slot number 2, the value of I will be incremented to 1. And after that, at time slot number 3, the process 1 will suspend it, and the value of I will no longer change. It will be paused at 1. And then at time slot number 4, the value of j will be multiplied with 2, and it will become 2. Then again, 4 time slots later, the value of j will again get multiplied by 2, and it will change to 4. And at time slot number 10, the simulation will stop. So without any further delay, let's just compile the code and open the QuestaSim. So let's check whether I have made any typos. Okay, we do not have any errors. So let's start the simulation. So let's check what is happening right here. I have to do a better work with the formatting, and we will do that during our next simulation run. So as you can see it right here, that at time slot number 0, our $monitor system task print the initial values of both the counters, which is 0 for I and 1 for J. Then at time slot number 2, as you can see it right here, our value of I is incremented by 1, and we get 1 right here. And then at time slot number 3, we just pause the thread number 1. So the value of I will no longer increase, and it will not increment to 2, as you can see it right here. So at time slot number 4, the value of I remains 1. So as you can see it right here, we haven't suspended the value of the thread number 2. So you can see it right here that the value of J is multiplied by 2, and we get 2. Then 4 time units later, we get the value of J again multiplied by 2, and we get 4. Then again at 4 time unit later, we get 8. And at time slot number at 13 time units, we stop the simulation, which you can see it right here. So this is the usage of suspend. It just pause the thread, and you could see it that the value of J is changing, but the I is not. So let us use the other method, and before that I will just modify my $monitor. And here, instead of stop, let us just suspend the process 2 as well, or the thread 2. So here we could just write that thread 1 pauses at 3 time units, and then at 13 time units, thread 2 pauses. And then what I will do, 5 time units later, let us use the resume method. So resume method is the opposite of suspend. It just resume the thread. So here I will resume the flow of the process 1. So we could just say at 13 plus 5, that is at time slot 18, thread 1 continues. And then after that, what we will do, we will just print the status of both the process. And as I have already mentioned, that the status method has 3 labels, and those are running, suspended, and finish. Since at this point the process 2 is suspended, it should print suspended, and the process 1 is resumed, so it should print running. So let's use $display system task. And here we will just print the labels, so we will use the string format, and we have to do the same thing. We just have to use the status method. So first I will print the status of the process 1, and then I will use another $display system task, and I will do the same thing for the thread number 2. And then right after that, at one time unit later, I will just stop the simulation. So let's check the status of both the process. I will compile the code again. Let's start the simulation. And let's run the simulation. So you could see it right here that till slot number 12 we are getting the same value, and here we are printing here at time slot number 12, not at 12, at time slot number 18 we have resumed the thread 1, and before that we have printed the process, the status of the process. And you could see that, okay, not before that, at time slot number 18 we have resumed the process 1, and we did use the status method to print the status of both the processes. And you could see for the process 1 it shows the running label, and for the process 2 it shows the suspended label, because we did suspend the process 2 right here at 13 time units. And after that, 1 time units later we stopped the process, but we did see a change of value at time slot 18 because we have resumed the process 1 right here, and the value of counter I gets incremented to 2. So this is the usage of the status and the resume method. So after that, what I will do, I will also resume the process 2 or the thread number 2, and I will do that 2 time units later. So at 2 units later, or at 20 time units, process or thread 2 is resumed. And what I will do, we have one method, and that is called await. And now here I will show you the usage of await. And 1 time units later I will use await for thread number 2. So await is a very powerful method, and what it will do, it will block the flow of the code here, which is line number 38, and the later statements will not be executed until the process, which is, just a second, I will write it in another line just to make it more readable, until the process, which is process 2 in our case, finishes. So await is kind of very similar to wait fork. It will wait the flow or the control of the program in this line, and this stop will not be executed, and it will not be executed until the particular thread, the targeted thread or the process finishes. And as I have already mentioned, this process will execute 7 times in a row until unless till it receives a value of 128 for the counter variable j. So what will happen when we will use await right here? It will not do whatever is written in the next line, and all the threads will keep on executing and will proceed until the process 2 finishes. So both the process 1 and process 2 in line number 28 are resumed, and they will keep on executing until the process 2 finishes. And it is more practical to use it for the process 2 since process 1 has an infinite loop and it will never finish. So right after that I will use the remaining method, which is kill, and I will use it to kill process 1. One time units later. So here I will just repeat the flow of the code. At line number 38, the entire code flow will get blocked, and we will not, and the SystemVerilog will not execute this particular statement, which is kill, which will kill the process number 1, and it will remain blocked till all the loops of the j occurs, and till we get the value of 128 for j. And when we get the value of 128 for j, this line will execute and it will kill the process 1, which has an infinite loop. So without any further delay, let's execute this code. I will compile this code again. I will start the simulation. And I will run the simulation. So let's observe what is happening right here. So till here, everything went well and it happened as per our expectation. But after that, at 20 time units, we resumed the process 2 or the thread 2. So after that, at 20 time units, uh, which is 2 time units after the 18 time unit, we get a value of 3 for I, because here in our infinite loop it will get incremented after every 2 time units. So here we get a value of 3 for j, and then at 20 time units we also resume the thread 2. So 8 gets multiplied with 2 and we get a value of 16 for j. and I have written it right here that at 20 time units thread 2 is resumed. Then at 21 time unit we block the flow of the code right here, and it will keep on executing till we reach the end of this particular repeat loop. So here you could see it right here that 2 time units later the value of j is incremented to 4, and the value of I increments to 4, and the value of j remains the same since it changes after every 4 time units. Then at 24 time units we get the value of 32 for j and the value of 5 for I. Then at 26 time units the value of j remains 32 and the value of I increments to 6. Then at 28 time units the value of j multiplies to 64 and the value of I increments to 7. And then at 30 time units the value of I increments to 8 and the value of j remains the same. And finally at 32 time units we get the last iteration of the loop, and we get the last value of j, which is 128, as I have discussed right here. And right after that, and on the same time unit, on the same time slot, we also get a value of 9 for I. It gets incremented by 1 when you see the previous value of 8. And right after that, this particular line executes, which says to kill the process 1. And we do that at the very next time slot. So we do not get any further value for I. We were supposed to get 10, but since we killed the process right here, the overall simulation quits right here, and the value of j has received its maximum value. So by this time the thread 2 has already finished executing, and here is the entire flow of the code. So this is sort of more fine-grained control as compared to the wait fork and disable fork. Just remember, you have to use the scope resolution operator inside the particular method, and you have to assign the handle of that task or of that thread to the handles of the process class, which you have to declare first. And right after that you could use another initial block in parallel, and inside that you will be using 4 methods: the suspend method, which pauses the thread; the resume method, which just resumes the thread; the await method, which locks the flow of the code till that thread finishes; and the status method, which is an enum type, which has 3 labels: running, which says that the thread is currently running; suspended, which says the thread has been suspended; and finish, which says the thread has been finished. And finally the kill method, which is very similar to disable fork, which just kills the thread. So if you will use let's say the status method right here, it will show that the process 2 has been finished. So let's go ahead and use the status method right here. I will just copy paste it. And I will just compile the code again. as you can see it right here, that it is showing that the process 2 has been finished. So that's all about approach to more fine-grained process control using the process class, which is a built-in class provided by SystemVerilog. And also I will be assigning the link to this code in the video's description. So I hope you find this video useful. Please stay tuned for more. Thank you so much.